In this video, we're going to talk about trigonometric functions of any angle. We're going to talk about reference triangles and then look at some examples. So a reference triangle is formed by drawing a perpendicular line from the terminal ray of a standard position angle to the x-axis. So if you look at the pictures I have below, this shows our reference triangle in each one of the four quadrants. So if we look at the first one, this is my terminal side of my angle, and I dropped a perpendicular line to the x-axis, which is then going to form my right triangle. I can then use this reference triangle to find the 6 trigonometric functions of any angle. So we have this point right here, point P, is a point on the terminal side of any angle theta in standard position. R is going to be our radius, or the distance from the origin to our point. Then the 6 trigonometric functions are defined as follows. So if we look at the picture I have over here, I've dropped that perpendicular line to the x-axis. So if I'm going from my origin to that line, I'm going to travel a distance of x. Same over here. This line, I'm traveling a distance of y. So my trigonometric functions are going to be defined as follows. Sine theta equals y over r, cosine theta equals x over r, and tan theta equals y over x. The cosecant, secant, and cotan functions are just going to be the reciprocals like we've previously talked about. So we're going to have the reciprocal. For cosecant, we have r over y, secant, we have r over x, and cotangent, the reciprocal to tangent being x over y. So let's take a minute to kind of talk about why these relationships are true. This whole time we've been dealing with SOHCAHTOA. Where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So again, if we look at our picture, if this is my angle theta, the side opposite of that is my y distance. So I would have the side opposite is my y distance, and then my radius is my hypotenuse to my triangle. Similarly, if we look at cosine, the side adjacent to that angle is that x distance, and r being the hypotenuse of my right triangle. Same thing with tangent. We have y being my opposite side and x being my adjacent side. So now you can really see where these ratios are coming from and how we can use them interchangeably with the SOHCAHTOA that we've been using thus far. So the next thing that we need to talk about is the sign of the trig functions will depend on which quadrant that the terminal side of our angle lies in. So if my terminal side of my angle lies in quadrant 1, which means I'm looking at this point right here and dropping that perpendicular line to form my right triangle, both x and y are positive. So when both x and y are positive, that means that all 6 of my trig functions are then also going to be positive. But if I have the terminal side of my angle in quadrant 2, so I'm talking about some point over there, my x distance is now negative and my y distance is positive. So looking at the relationships that we have over here, if my y is positive, then sine is going to be positive. And since x is negative, my cosine is going to be negative. Tangent, I have y over x. So if one of those numbers is negative, then the whole thing is going to be negative. So tan is also going to be negative in the second quadrant. If we look at the third quadrant, I have both values, x and y, to be negative. So in the third quadrant, If y is negative, then sine is going to be negative. If x is negative, then cosine is going to be negative. However, for tangent, I have a negative y over a negative x, which then makes tangent a positive answer. And last but not least, if we look at the terminal side being in our fourth quadrant, a point here, we're going to have a negative y value and a positive x value. So as far as our trig function goes, if we have a negative y value, then sine is going to be negative. If we have a positive x, then cosine is going to be positive. For tangent, if we have a negative y over a positive x, that's still going to leave us with a negative answer. So tangent is also going to be negative. So you can really see how it depends on which quadrant you're in that dictates the sign of your trig function. All right, so let's look at this first example. Our picture is already drawn. They gave us the point negative 12, 5. So that means that my x distance is negative 12 and my y distance is positive 5. So what they didn't give us is r. Well, how can we find r? If you remember the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, here our x1 and our y1 is the origin, which is at 0, 0. So if I plug in a 0 for x1 and a 0 for y1, those two terms are going to go away, and I'm left with just the square root of x squared plus y squared. Well, the distance between this first point at my origin and this second point that they gave me is in fact my r. So I have r equals the square root of x squared plus y squared. So I can now find r. r is going to equal the square root of negative 12 squared plus 5 squared, and that's going to give me 13. So now that I have all of my values, I can now find all 6 trigonometric functions. So we're going to start with sine theta. So on the previous screen, we said that sine theta is y over r. My y value is 5, and my r, which we just found, is 13. Cosine theta on the previous screen we said was x over r. X is negative 12 over my r is 13. Tan theta we said was y over x. Y is 5 and x is negative 12. Then we have cosecant theta. Cosecant theta, remember, is the reciprocal of sine. So I have r over y, 13 over 5. Secant theta, r over x, 13 over negative 12. And finally, cotan theta, x over y, negative 12 over 5. All right, so again, the first thing that we need to do on this next example is calculate r. So r equals the square root of x squared. So if we look at our drawing, my x they gave me is negative 2 square root 3 squared plus my y squared, which is negative 4 squared. And this gives me 12 plus 16, which is the square root of 28. And that simplifies to 2 root 7. All right, so now let's go ahead and make sure we have all the parts of my triangle labeled. So the x distance is negative 2 root 3. My y distance is negative 4. And my r we said was 2 square root 7. So now that we have all of our values of our reference triangle, we can find the 6 trigonometric functions. Sine theta, again, y over r. Y is negative 4. R is 2 root 7. That's going to simplify to negative 2 over root 7, but we don't want to leave that radical in the denominator, so I need to multiply both top and bottom by root 7, and that's going to give me negative 2 root 7 all over 7. Cosine theta, x over r. My x is negative 2 root 3. My r is 2 root 7. My 2's are going to cancel. So again, I don't want to leave that radical in the denominator, so multiplying both top and bottom by root 7. I now have negative root 3 times root 7, which is negative square root 21 over root 7 times root 7, which is just 7. Tan theta y over x. My y is negative 4. My x is negative 2 root 3. That's going to simplify to 2 over root 3. Getting rid of that radical in the denominator, I have 2 root 3 over 3. And again, just like we did in the previous example, you can find cosecant, secant, and cotangents just by taking the reciprocal of all of our answers here. All right, for our last example, we have the terminal side of an angle in standard position lies on the given line in the given quadrant. And we just want to find sine, cosine, and tangent of that angle. So in this case, they give us a line 5x minus 4y equal to 0. But really in this form, it doesn't really mean a whole lot to me. So I need to get it into y equals mx plus b form. So I'm going to move my 5x over. I get negative 4y equals negative 5x. Divide by my negative 4. And I get y equals 5 over 4x. All right, so the first thing that I want to do is draw a picture. It says that we're in quadrant 1. So using the equation of my line, I can draw my line, right? So we can plot our y-intercept, which is going to be at our origin. Then we have our slope, rise over run. So rise 5, 1, 2, 3, 4, 5. And then run is 4, 1, 2, 3, 4. So now I have my points, and I can draw the terminal side of my angle. So now it looks more familiar to what we've been doing. We have a point 4, comma 5. So my x distance is 4, my y distance is 5. But now I need to find out what r is. So r is the square root of x squared plus y squared. So then I have 4 squared plus 5 squared. So r equals the square root of 41. Now that I have all of my values, I can find sine theta y over r. My y distance is 5 over r, which we said was root 41. Getting rid of that radical, I have 5 root 41 over 41. Then I have cosine theta x over r. My x distance is 4. R is square root 41. Again, getting rid of that radical, I'm going to get 4 root 41 over 41. And then finally, tangent theta is y over x. My y is 5 and my x is 4. So that's really all you need to know to find trigonometric functions for any angle. Always remember to draw your reference triangle perpendicular to the x-axis to form that acute angle. And keep in mind that the sign of the trig functions will depend on which quadrant that the terminal side of your angle is in.